what's been covered in the previous session. Previous session, we are in the phase of creating the network, two different networks. One network is the default network where our tools like our Nexus, Workstation, all of them are there. And on the other hand, we created another VPC, virtual private cloud, where we have created a couple of networks, and also we calculated what is CIDR, and I want how many IP addresses, and what is 10 to 00024 gives me, and what is subnet, why you need a subnet, what is a router. All these things we discussed extensively, and then we also ensured if a virtual machine is created in the public subnet, it would be having a public IP and it should be having access to the internet. And at the same time, we also ensure that the machines that are launched in this have a internet connection. That means we established a route, and to keep that point in mind, so I just created the server. Okay, so I just started the public server, which is launched in the 10.00 series network. Now let's try to start ping google.com. Now you get a response from the internet. This is just a proof that you have access to the internet. If you want to check sudo yum install httpd, this is just a proof that you have access to the internet because it's going to the internet and fetching the package and publishing the package to you, right? Let's wait for it. Yes, that means it's going to the internet and downloading the packages. Fine. Now I'm okay. I'm fine. That's fine. Now how can I connect to the private lab server? Your private lab server cannot be accessed from the internet because it's not having a public IP address. Why it's not having a public IP address? Because we created that machine in the private network. If you create any of the machine in the private subnet, by default, they won't be having access to the internet. Okay, which also means they won't be having the public IP address. Okay, and how can I connect to it? Okay, if you want to connect to it, okay, so you need to SSH to this machine. In our case is a public server jump host. From this you need to SSH. Okay, so I just open the server SSH, so into SSH. Let me try to connect to the private server. Okay, come here. Let me try to name the server as private server just to set the context. Okay, so this is my public server and this is a private server. And just to prove curl ifconfig.co, this gives me not this curl config.me. This is giving me the public IP address, right? And if you try to do the same here, curl ifconfig.co or me, it gives me nothing because it doesn't have public IP address. Okay, and if you try to ping google.com, it won't be talking to the internet and it won't be having access to the internet. Now, if you want to update the patches, or if you want to download some packages, or if you want to update your repositories, if you don't have access to the internet, how can you achieve your goal? And also in organizations, it's not like you have one machine or 10 machines or 20 machines. You'll have hundreds and thousands of machines. Now, maintaining security and at the same time giving ease to the employees also makes a very important thing. If you are constructing a very tight security and trying to build a better perimeter, and that perimeter should protect the organization, but at the same time that also should never restrict your employees to proceeding further. That also means my main agenda is none of my machines should have access to the public IP address. That also means from outside the network, I shouldn't be in a position to connect to these machines. That's how I want to construct my perimeter. But at the same time, I also want to ensure if these machines wants to talk to the internet, that means if these guys wants to talk to the internet, they should be able to talk. That means access to the private machines from the internet should be disabled, but access to internet from the machine should be enabled. That means if the machine wants to talk, you should be able to talk. Okay, that's how I would like to design. Okay, so in order to achieve this, we have a component called as NAT gateway. Okay, this is called as a NAT gateway. Okay, this NAT gateway helps you in achieving this goal. What are we going to do is we are going to create a NAT gateway. Okay, so again, NAT gateways are of two types: public NAT gateway and private NAT gateway. My NAT gateway is used to give public access to it. Okay, in order to use this, you need to create a NAT gateway and you need to attach it to the subnet that is having access to the internet. Okay, this is a very important question, how to use NAT. Okay, so NAT stands for network address translation. Here the main job of this NAT is to establish communication to the internet. So this gives a hop network. That means this cannot directly access internet, but we are going to create this component and this should only be added to the network that is having access to the internet. Now I'm going to tell here okay, to the same route table. Even private subnet should also be having a private route table. Is a private route table. Now I am gonna tell to this route table, hey, if you want to talk to the internet, that means if you want to talk to 0000, that means if you want to talk to the internet, then go and talk to this public subnet, and this guy will let the connect to the internet. Okay, that's how the communication will happen. Okay, that's how we are going to do, and let's try to see that. Okay, so let me go here. NAT is a VPC component, which means it is a component in the VPC service. VPC stands for Virtual Private Cloud, which is a network as a service in AWS Cloud. Come here and here look for the NAT gateway component. Yeah, click on this. Now, I do not have any NAT gateway components. Again, NAT components are not free. They are extremely costly. So ensure you delete them once you done with the practice. Okay. Also in the same session, I'm also going to show you how to delete everything, because if you're not using Terraform, you need to delete it in a way exactly the reverse order of how we have created. Okay, I'm gonna show you all these things in the upcoming at the end of the session. But for now, I would like to name it as a lab NAT gateway. Okay, we are following the naming standard. Okay, just by looking at this, I should understand what is the VPC that it belongs to. Since my VPC name is lab, so I'm just using this. And where you want to attach it, you should always attach the NAT gateway to the subnet that has access to the internet. So I should attach it to the lab private subnet or lab public subnet. Anyone? Where should I attach it now? Satish.
Public.
Exactly. Perfect. Okay, and the connectivity type, public connection or private connection. But you can also use private. The use case of private NAT gateway, we'll talk about it later. But for now, in order to achieve the connection, the connectivity should be public. And also, whenever you create a component called as a NAT gateway, it needs a public IP. Okay, because it establishes communication to the internet, it needs to have an elastic IP. So elastic IP is a service which gives you the static IP address to the NAT gateway. So again, this is also not free. Ensure you release them once you're done with the practice. Okay, I'm just explicitly mentioning just to ensure you don't be charged unnecessarily. I would like to allocate it. If you already have an IP address, you can still use it. Create the NAT gateway. Now this NAT gateway is created and will be attached to the subnet that is having access to the internet. Now, now you come here and try to see, still it won't work. Can anyone tell why it's not working? Anyone? Based on what we learned yesterday? Anyone? Anyone? What could be the reason why it's not able to access? We encountered this yesterday. We fixed it, but from the other way around. Anyone? Why?
Route table.
Exactly. You need to tell if you want to talk to internet, use this route. So come here So create a route table. We don't have any route table for this lab public RT, right? Similarly, let's follow the same standard. Standard is very, very important with respect to naming standard. Okay. And you need to create in a lab VPC. And yeah, that's it. Once the lab route table, lab private route table is created, I would like to attach it. So to which subnet I should attach this? Public or private? Who's going to answer? To which subnet I need to attach this route table? Prem, Kumanan.
Private subnet.
Exactly. Yes. Okay. I'm here. Now you need to add a route. So what is the route I need to add? Now it is telling only if you want to talk to local network, use this local communication. But I want to add a route. What should be the route? Anyone? If it want to talk to the internet, what it has to use? See the diagram. If it wants to talk to internet, what is the hop it has to use? Okay. So you need to tell I want to talk to the NAT gateway. What is the NAT gateway available? That's it. Save it. Okay, now it has access to the internet. Let's try to validate, and also immediately it won't work. It sometimes it takes 1 to 3 minutes of time. Don't worry if it don't work immediately. Wait for 1 to 2 minutes. In my case, it worked immediately. And if you see this earlier, you didn't get a response. Now you're getting a response. Even though it is a private server, it won't be having any sort of public IP address. That means this machine cannot be contacted by others in the internet directly. But if this machine wants to talk to the internet, yes, it can do that. For example, let me try to install Nginx. See, it's going and installing. Is it clear? Is it clear, guys? All right. Now, this is how we can achieve, okay, the outside to the inside and inside to outside. Okay, fine. Okay, fine. Now I have my workstation ready, right? Now both the machines can talk to each other using the private IP address, right? Now if it wants to talk SSH to 10.0.0.69, it works because both of them public machine and private machine are on the same VPC. That means both of them are in the same subnet, so they can talk to each other, right? But what if you have your workstation, right? So start your workstation. Okay, so go to the workstation. Let me connect to the workstation. I started my workstation before the session itself. So come here. Let me try to connect to my workstation. This is my workstation. Okay, so your public subnet, your public machine and private machine, both of them are in the lab VPC 10 series network. Okay, carefully observe that. SSH CentOS at the rate this. Okay, and if you see this machine is a workstation which is available in the 172.31.20.237 network. 172.31.20.237 network. Now, if I want to talk to this machine, let's see whether it works or not. Okay, I would like to SSH to this machine. And what is the public IP address of it? This is the public IP address of it. So SSH. I'm SSHing. Okay, that means I'm connecting from my 172 network to 10 series network. I know I entered the wrong password. Can you see this? You are connected, right? 10069, 10069. That means you are able to connect from external network to internal network. But the connection is not over the internet. It is internet. That means it has to go through the across the oceans. Okay, even though they are in the next building, still it has to go to the internet. Again, it has to come up, and again if the machines are on the same project, it's not secure to use a public IP address. And when the moment you use the public IP address, the communication will go over the internet. That means it goes outside your network, which is not secure, which is not relatively secure. And at the same time, if something goes over the internet, the time taken is very, very high. Okay, so for example, if you are working for a gaming company, or if your applications are latency sensitive applications, you cannot accommodate that much amount of time. So in order to break that, and in order to achieve communication between both of these networks, okay, seamlessly, just like IP addresses, okay, you can use something called as peering. Okay, you can use something called as network peering. This helps in ensuring your communication between the two networks is trunked, okay, or is okay. The moment you do that, both of them can talk to each other using a private IP address. Okay, so this is called as a network peering, which we already discussed yesterday. So if we establish this 172 series network can talk to this 172.series/16 network can talk to 10 series network without the need of public IP address. That means the communication is over the intranet, over the Amazon's backbone network, so that your communication is highly secure. And since the net traffic is not going outside the network, communication will be really, really, really quick. So how can I do that? Okay, so let me try to show you that. Again, this concept is called as a network peering or VPC peering. Okay, in the core networking terminology, we call this as a trunking the network. But in the terminology of the VPC, in the cloud context, we call it as a peering. So this peering can be established, okay, earlier. The restrictions are like both the network should be in the same VPC, same account, and both of them should be in the same region. Earlier, 4 or 5 years back. Now, 3 years back, they removed that restriction. You can do the peering between two different accounts as well. This VPC can be in the different account, and this VPC can be in the different account, but both of them should be in the same region. Like both of them should be in the North Virginia. Now, 1.5 years back, they also removed that restriction. This VPC can be in a different account, different region, and this VPC can be in a different account, different region. Okay, but both of the account holders has to accept, hey, I'm ready to accept the connection. Hey, I'm ready to accept the connection. This needs to be done. Okay, so let's try to see that. You can come here in the peering. So there is an option in the VPC called as VPC peering. Yeah, come here, peering connection. Now there is no peering established. Now create a peering connection. Now you need to tell the peering name default VPC to default to a lab VPC peering. Just give some name that makes sense. Okay, as per the instruction, as per, yeah. So select a local VPC to peer with. Okay, in my case, okay, I want to establish communication from this VPC, okay, which is a 172 series network, and it is asking where is your other network. Okay, you need to mention whether it is in my account or in the other account. If it is in the other account, you need to add the account details here. Okay, if not, just mention. And it's also asking you whether it is in the same region, North Virginia, or in the different region. Okay, I can say that this is also in the same region, so you can find the lab VPC. Source is default VPC, and it is a lab VPC. So I'm establishing communication between default VPC to the lab VPC. Let's try to see whether it works or not. Okay, you can come here, and if you see this, the peering connection, what it says, pending acceptance. Okay, it's not like, okay, if Prem is in a different account, I'm in a different account. If I just say establish peering, it won't be established. Prem, who is the other account owner, has to accept it. Then only it works. In my case, both of the VPCs are in the same account, and that's the reason I'll get an option to accept it. Okay. Now, the moment you accept it, it will work. Okay, it's also suggesting you something, but I'm not going to do that right now. Now, let's try to attempt to connect from your workstation, default network to 10.0.0.69. Let's see whether it works or not. Or just do a telnet. That's easy. Can anyone tell why it's not working? Anyone? Why it's not working?
We need to accept the peering from private server.
We already accepted it, right? We already accepted. And if you come here and check the status is active. Agree?
Okay.
So let me go back to diagram. Here in the route table and also here in the route table, I need to mention, hey, if any of the requests are coming from 172.31.0.0.0/16, use the peering connection. I need to tell it, right? Agree or not? Okay. So not just that, if the requests are coming from here to here, you need to update it. But similarly, even in the same public subnet, even here you'll have a route table, right? Where your workstation is there. Agree or not? So here also you need to mention. Okay. So go to your workstation and your workstation. Okay. If you want to know what is the associated route table, click on the subnet. Click on the subnet. And if you click on the subnet, you can check a route table. Okay. It is one route table is attached. You can click on the edit table. You can click on the route table, and here right now, okay, the routes are enabled is 170.31. If anyone wants to talk to this, that is telling use the local network. And if the requests are coming from 170.0.0.0, use the NAT gateway. Similarly, I also want to add a route. So come here is the route. Edit the route. Okay, here I need to mention if anyone wants to talk to 10.0.0.0.24 network, use the peering connection. I need to tell that. Come here. I would like to add a route. I'd like to say 10.0.0.0.0. If anyone wants to talk to this internet, so what they need to use? Network, instance, or NAT gateway, or what they need to use? If the default machine, if the workstation which is in the default network wants to talk to the machine that is available in the different network, okay, which is peered, what is it has to use? Either it has to use carrier gateway or internet gateway or NAT gateway. Which one to use? Anyone? 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 Kaushik or Satish? Anyone? Anyone?
Peering connection.
Exactly. Peering. You need to mention the name of the peering is this. So save the changes. Done. Now the peering is established and you also enable the routes. And if you try to do the same thing, let's see whether it works or not. Okay, it takes little time, 10.0.0, but it will work. Okay. Now, similarly, you also need to tell the route tables of the private machines also use this network. Okay. So here in the lab public server, you have a couple of route tables, right? Go to the route tables. For the other, also you need to mention, come here and say, if anyone wants to talk to 172.31 network, add a route. If you want to talk to 172.31.0.0.16 network, use the peering connection, and the name of the peering connection is this. Similarly, you also need to go to the, okay, similarly, you also need to go to the other route table and should also be doing the same. Come here and try to do that. Okay. Come here and add the routes. Now for both the machines we mentioned, that means in both the ways we established the route. Okay, that means we told our public route table in the default, hey, use the peering connection if you want to go to 10 series network. Similarly, we also told to both the subnets, if you want to reach to 172.31 network, please use the VPN connection. That means for all the three subnets, for all the three route tables, we told what to go. Now give it a try and see whether it works or not. Take some amount of time. So maybe 10, 10, 10. 10.0.0.69. Why it's not working? Now go to the workstation and look at the networking and the subnet and the associated route table. And click this. It's a 172.31 series network. And if you want to go to 10.0.0 network, right? 10.0.0.24. So let me validate the subnet details. It takes a little time, okay? So here, lab VPC, and the network range is 10.0.0.24 and 172.31 series network. So there is no changes in that. Okay, so here, it's a workstation. Ah, so 10.0.0.24, it's a peering connection. It should work. Why it's not working? Similarly, I also want to establish the communication from here. Telnet. I just want to use 172.31.20. For both the ways, communication is not happening. What could be the reason? Let's try to analyze it. Okay, so let's try to analyze and see what's happening. Okay, so route is there. It's 10.0.0.0.24 network. And this network is 172.31.0.0.16. Go to the route tables, and in the lab private route table, which is associated with the lab private subnet, and the routes that are established are, okay, you can clearly see if you want to talk to 172.31.0.0/16, use this. Similarly, for the public route table, I mean public subnet route table, the routes are defined the same. If you want to talk to 170, where is the route for the public machine? Let's try to add the route. 172.31.0.0.16, then use the peering connection. Okay, done. So let's try that. Why it's taking time? Can you see this, guys? Now your workstation is able to talk to this over the public network. Can you see this, guys? Guys, can you see this? Now your workstation 172 series network is able to talk to, okay, this network without the need of, okay, public IP address. Now I can use this to connect SSH, CentOS at the rate, this one, 10.0.0.69. It works. Okay, so now we have established the communication. That means from my workstation, okay, I am able to connect to the public machine. Similarly, let's also check whether my workstation is able to talk to the machine private subnet or not, which is in a private network. Let's try to see that. Telnet 110.0.0.166, and I want to talk on port number 22. Okay, and if you see, it is the connection is established. You can also directly SSH to it. Okay, let's try to see that SSH. Password 123, and you can see that you're able to connect. And similarly, it also works the other way. And if you want to talk to, if my private machine wants to talk to workstation, yes, that should be possible. SSH 172.31.20.237. Okay, see? Can you see this? Even my private machine can talk to the workstation, which is present in a different network over its private network. That's the beauty of it. Okay, try to check a connection. Okay, that's good.
237.
Manoj, the private
You are giving 137.
Mhm.
the IP
Sorry.
address you entering wrong IP address.
Why? Why it's wrong?
No, you mentioned last 137. It is 237.
Okay, I get it. So it's 237, right? Yeah. Thank you. 20.237. Now it will work. That means your public server is able to talk to the workstation which is in a different network. So by from 10 series to 172 series network and 172 series to 10 series network, we have achieved the communication. We have achieved the communication. That's the beauty of peering and NAT gateway. We enable the communication between two different networks, and also we understood how can we plan the network and how can we scale the network is something we saw. And we also established the strategy to establish communication to the machines that are present in the private subnet, even though they don't have a public IP address. Okay, this is one of the most important strategy. With these things in place, I think we are sufficient enough to kickstart implementing the project networking strategy. So the project networking strategy is something we want to implement, and this is a strategy that I want to implement from tomorrow. Okay, we are going to achieve this. Okay, so this network is already there, and we are going to create a production VPC, and we are also going to create a development VPC, and then we are going to proceed from there. Okay, also how many IP addresses do we need, okay, for production, and how many networks we are going to create, and what is the strategy, all these things we're going to see in the upcoming session. And that's for today. And yeah, and whatever we are going to discuss so far, everything we are going to deal in the Terraform way. Okay, and that's for today's session. And I would like to keep the session short in the interest of time because we have limited audience, and tomorrow is a festival so in India. So let's happy Ganesh Chaturthi everyone. So yeah, have a great festival by the way. And also before we wrap the session, I also want to show you how to delete them. Okay, so first go ahead and delete the machines, lab private machine and lab public machine. Okay, so if you're doing with Terraform, you don't have to follow all these things. Okay, because Terraform apply is going to create everything in an order which it know, and Terraform destroy is also going to delete all of them together in a shot when it has to create. And if you might think, hey Manu, everything is on the top of the VPC, right? What if you directly delete the VPC? That's a great point. Let's try to see that what will happen. Come here, I like to delete my lab VPC. Come here and see what will happen. What it says you have some dependencies. That's the reason it will not work. So we deleted the instances, right? And then we also have a lab machine. Let's terminate that as well. No. So we also have security groups that are attached to those machines. Come here, public and private. Delete this. Okay, it will not be deleted because the machine that is attached to this is still undergoing the down. Lab. Let's wait. What happened to the machines? Are they still going down? Let's terminate it. Yeah, this is in the stop state. So let's terminate this as well. Okay, also delete the underlying route tables. You can come here and delete the route tables of the public and private. Delete this. And also you can see that there are routes cannot be deleted because a peering connection is there. So go ahead and delete the peering connection. So you need to follow all this flow, right? It is a painful task. So you see a very clean thing if you use Terraform. It says delete the route table entries as well. Wherever it is telling, hey, if you delete this peering connection, there are some route tables where this peer is used, and those are going to be impacted. Till 6 months back, okay, when you try to delete an entry which is being mentioned in security group or in the route table, it is going to show as a black hole. Now it is clearly asking, okay, do you want to terminate that as well? Okay, so I'm telling yes, go ahead. Now I deleted the peering connection. Now I do not have any sort of peering connections as well. Now route tables that are associated were also deleted. Now the security groups, just go ahead and delete the security groups. Also NAT gateway, I do not want the NAT gateway as well. So let's try to delete the NAT gateway. It's a very costly component. So please ensure you delete the NAT gateway as well. So delete the NAT gateway. I don't want it. And NAT gateway has an elastic IP. So ensure you remove that as well. Release the, okay, it cannot be released because it is associated. So you need to wait for some time. So route tables are deleted, subnets. Let's try to delete the subnets, see what will happen. I know sub security groups are there on it, so maybe it should trouble us. Wonderful. So delete this one. Now we have deleted everything. Lab public subnet. So let's try to delete that as well. Done. Now lab public subnet and lab private subnet, both of them are created, and you have a way to destroy it now. Okay. Whatever the order we went through, we exactly went the reverse way. All right. And that's it. And you also have an elastic IP left, and just wait for some time and release it. It would be released. Okay, it says it cannot be because it is attached to the NAT gateway. Just wait for some time and then delete it. It should go away. Okay, and you can also see that the NAT gateway is deleted. It takes 2 to 5 minutes of time, and then okay, you can remove the public IP address that is attached to it. And that's for today. And tomorrow we are not going to have a session, and we're gonna meet again on Tuesday. And that's for today. Signing off for the day, and have a great festival, guys. Okay. Thank you. Signing off. Okay. See you guys.